Hi, welcome to this video. We are going to talk about the lowest common denominator, also known as the LCD for rational equations, and excluded values, values that make the denominator zero. So let's go ahead and jump in. You'll be successful if you can factor a polynomial completely. You can identify common factors and you can solve a linear equation. So I want you to know, first of all, that a rational equation is an equation that involves at least one rational expression where we have a variable in the denominator. So both of these are rational equations because we have equations, something equal to another, and notice we have variables in the denominator. Rational equations with three or more terms cannot be solved using cross multiplication like a proportion. So for instance, this example here, we cannot do the butterfly method, right, or cross multiply. Instead, we have to get rid of all of the factors in the denominator by multiplying by the lowest common denominator, also known as the LCD. It's the product of all the common factors that they have that are shared between two or more denominators, and then anything that's left over. So when I multiply by an LCD, it'll clear out everything in the denominator. So here's an example of what a factored rational equation looks like. And if my LCD, if I take everything that's shared, so my shared factor, look who interrupted me. And so the factors that are shared here, if I have an x plus 6, so notice I have an x plus 6, that's shared. So that's going to be one of my shared factors. And then I have these other ones that don't match. So they're going to be left over. These are remaining factors. So an x minus 6, a 2, and an x. And I need all of these in order to cancel. So when I go ahead and multiply, right, if I multiply by a 2, it's going to cancel with this 2. If I multiply by x, it's going to cancel with this x. If I multiply by x plus 6, it's going to cancel both of these, and then the x minus 6, okay? So how do you find the LCD? We're going to do that in an example here below. You'll factor each denominator. Notice in this example, everything's factored. You'll identify common factors. Notice I did that first. I just said, hey, what's the same? If all three of them share it, then we take it. And then anything that's remaining or left over, we will take those. Okay, that will be the LCD. It's the product of all the shared factors, in this case, example, x plus 6, and then anything that is remaining. What we will also do is we'll talk about excluded values in this lesson. These are values that are left out of the domain because if I plug in this number, it creates a 0 in the denominator. We cannot divide by 0. So excluded values of a rational function are values of the variable that create a 0 in any denominator. And this means that we cannot use any x value that creates a 0, since that will be an undefined value when we divide by 0. So we exclude these. And I'll give you an example here. If I have x over x minus 8 equals x over 3, 8 would be an excluded value, because if I take x minus 8 and I set it equal to 0 and I solve, this gives me x is equal to 8. Plug in 8, I get a 0 in the denominator. No good. So how do we find excluded values? Well, you're going to factor each denominator completely, find the LCD, set the factor that includes an x, very important, to 0, and then you solve. Those are your excluded values, okay? That's the concept. Let's go ahead and look at an example here. Example 1 says find the lowest common denominator and the excluded values of each equation. Step 1 that we're going to do always is factor. Our good old friend factoring. It never goes away. So our first denominator is a difference of two squares, x minus 3, x plus 3. Our second term is an x minus 3. And then I have 5 over 3. Okay, so here we're going to go ahead and identify what's shared. If I'm trying to generate my lowest common denominator here, are there anything that's shared? I'm only going to take one of. Yeah, an x minus 3. Because if I multiply by x minus 3, it'll wipe out both of those x minus 3's. And we'll see that in a future lesson. And then, after I do this, what is remaining, or what is left over? What is left over? Well, I have an x plus 3. That's right here. And then it looks like I have a 3. I'm going to put that out front. So notice the 3 is different from the x minus 3. If it has a minus or a plus, that's one package. It does not match. The 3 does not match. Okay, so x minus 3, that's one thing. X plus 3, that's another thing. And then 3 That's a completely different thing. So here's my LCD, and I'll also talk about excluded values here in this portion too. Really easy to do from this stage. I'm just going to go ahead and set the value from the factor that would create a 0. So x minus 3, and it's similar to what we did in identifying h. What value would make this factor 0? Well, 3, right? 3 minus 3. So it's kind of like the opposite value that you see. And then how about from x plus 3? What would make x plus 3 0? Well, it's going to be negative 3, right? Negative 3. That would give me a 0. So these are your excluded values. X cannot equal these values. And now you're saying, hey, what about this 3 right here? Well, is 3 ever going to be equal to 0? No, it's not. It's a 3. So we kind of ignore it. Okay? That's example 1. Example 2. Let's go ahead and do it again. Step 1, I'm going to go ahead and factor. So I have a GCF of an x here. X squared minus x. I'm going to take out an x. So I get x times x minus 1 plus, in my denominator, I have x plus 1, x minus 1. Difference of 2 squares there. And then we have 3 over x. Okay? So what is our LCD? Well, we're going to take whatever is shared. So what's sharing? Oh, I got an x. And it looks like I have an x minus 1. So x minus 1. I only take one of them. If it's shared, you only take one. And then what's left over? X plus 1. Okay? How do you find your LCD? Very important question. Make sure you know this. I take the shared factors and any remaining factors. That's your LCD. Okay? What's excluded values? Well, anything that's going to make these denominators equal to 0. Okay? So that's going to include 0, right? If I set x equal to 0, it's 0. X minus 1, hey, that's going to be 1. 1. And then how about x plus 1? Well, that's going to be negative 1. So here's your excluded values, and I always like to include x cannot be equal to. So these are the values we are leaving out. A question that often comes up, what about the numerators? Do I do anything with the numerators? Nope. Pretty much for this lesson, you're ignoring the numerators. We're only concerned about finding the lowest common denominator. Notice numerator is not part of that. Okay, let's have you. Let's do this one. I'll break it up because I've been talking a lot. I want you to try this one in the middle. We'll wait on this one, but please pause me. I want you to find the LCD of this, and then we'll do excluded values after. Okay, so find the LCD. Pause me. I'll show you the answer here in a second. Okay, here you go. If you factor this, factor your denominator. I have a GCF here, and then we have difference of 2 squares. Looks like x is shared. Or no, x is not shared. Just x plus 2 and an x minus 2. Why does this one not have parentheses? I don't know. Sometimes they include the parentheses, sometimes not. I like to include the parentheses, just to make sure you know it's one package. But there's your LCD. Did you get it? Awesome. Now, what are your excluded values? Pause me. I want you to try to find the excluded values. X cannot equal what values are restricted? Hopefully you did that. X, that's going to give me 0. X minus 2, that's going to give me 2. X plus 2, that's going to give me negative 2. And again, algebraically, how do we do this? You just take x plus 2, you set it equal to 0. It cannot equal 0. So you solve. And that's how we get that negative 2. Okay? All right, hopefully you tried that. Let me go over a couple of more examples for you. Here in this example, this is unique because of the second term. I have 8 over x minus 2 plus 2 is equal to 4 over 3x minus 6. Step 1 is always to factor, so we can just check and see, do I have anything to factor, as well as this 2. It doesn't have a denominator, or it doesn't appear to. It does. It's a 1. It's fairly trivial. We can kind of ignore it, but it does have a denominator. It's 1. And then over here, we have 4 divided by a GCF of 3, which produces an x minus 2, okay? So what's our lowest common denominator? Well, it looks like I have an x minus 2 that's shared. And then what's left over? I have a 3. And I don't really need to include a multiplier of 1. Doesn't do anything, right? So there's your LCD. That's it. That's really the only new wrinkle here. Excluded value, x cannot equal 2. The 3 does nothing for us. Okay, it's never going to change. I don't have to worry about it. Set it and forget it. Okay, All right, probably the most difficult example, just because of the factorization. And if you feel good about your factorization, really this problem is no different and not difficult at all. X squared plus 7x plus 10, no GCF. That's what I always check for first. And then I want to open up two sets of binomials. Please pause me here. Can you factor this? What do you get? Hopefully you got 5 and 2. X plus 5, x plus 2. And then x plus 5 over here. Okay, so what's our lowest common denominator? Well, what's shared? I got a x plus 5. Ooh, look, all three of them have one. This one, and this one. I still take 1. I still take 1. Now, if this was x plus 5 times x plus 5, I would take another x plus 5, but we don't. So each term has one. We only take 1, and then the leftover. Excluded values. X cannot equal. Who are the bad numbers that create 0 in a denominator? -5. Ooh, bad number. 2? No, 2's fine. Its opposite is not okay. -2. There you go. So that's how we find lowest common denominators and excluded values. Hopefully you feel comfortable. Here is a couple of practice ones. Please find the LCD and the excluded value. When you unpause me, I'll show you the answer here. Okay, hopefully you went ahead and took out a GCF in your first term. I like to add a 1 in this denominator just so it doesn't throw me off. But our LCD is 4 times x plus 3. Excluded value is only -3. That's the only one we have to worry about. Did you get it? Okay, last practice one. Please pause me, try this example here. I wanted to check in with you and see if you got your factorization correctly. So this first trinomial is x minus 4 times x plus 1. Nothing to do with the second term, and then the third term, x, is a GCF. So we have x times x minus 4 once we factor that out. Did you get that? Double check that. Okay, pause me, and we'll show you the LCD here in a second. Okay, here is the LCD. We have a shared x minus 4, and then an x plus 1. So that's your LCD. Excluded values. Go ahead, pause me for excluded values. X cannot equal what? What are they? Hopefully it's quick and easy. 0, 4, and -1 are what you should have gotten. Okay? All right, in this video, we went ahead and we learned what the lowest common denominator is. Remember, we have to factor a rational equation, take anything that's shared and anything remaining, that's your lowest common denominator, and then excluded values. These are values that make our denominator 0. We cannot include them because they create division by 0, which is a no-no. All right, give this video a thumbs up, like it, subscribe, share. I'll catch you next time.